Welcome to another class. I want to first of all congratulate Confidence Omenihu. He is the person that got the answer to the previous assignment in physics of the people that submitted the assignments. He is the one that got it. Congratulations to you, Confidence Omenihu. And I want to use this medium and tell you to subscribe to the YouTube channel so that you'll be getting information whenever class is uploaded. You will get it as a notification, and then you will participate immediately and be able to do your assignment. Now, today we want to continue from where we stopped in the previous class. We want to look at connection in parallel. Last class we stopped at connection in series. Now, both resistors and cells can be connected in parallel. How does parallel connection look? If you look at the board, you will see how resistors can be connected in parallel. I'm using two resistors here as an example, 1 and 2. This type of connection is parallel connection. And to find the effective resistance in the circuit, you will use the expression 1 over R is equal to 1 over R1 plus 1 over R2, where R is the effective resistance, R1 and R2 are the given resistors. When cells are connected in parallel, look at how it is. This sign shows that they are connected in parallel. And the effective voltage will be equal to the value of each of the voltage because they are connected in parallel. That means that there is no further simplification that you are doing or calculation. Whatever be the value of V1 will definitely be the same value as V2 and will be the value of the effective resistance. From what I explained in the first class, that only cells of the same capacity can be connected. Now let's see how an example will look like. Two resistors, 2 ohms and 4 ohms, are connected in parallel in a circuit in which 2 cells, each of 2.66 volts, are connected in parallel. The first is for you to draw the circuit diagram. And the second question is calculate the current flowing in the circuit. And then the third question is what is the quantity of charge that flows in the circuit after 1.5 minutes. So you can see the diagram. These are the 2 resistors, 2 ohms and 4 ohms connected in parallel. And these are the cells also connected in parallel. So let's apply what we have said. We have the total or effective resistance will now be 1 over R is equal to 1 over R1 plus 1 over R2, which will give us 1 over R is equal to 1 over 2, that's R1, plus 1 over 4, that is R2. In this case, this is addition of fractions. You find the LCM. LCM of 2 and 4 is 4. And then you say 2 dividing 4 is what? 2. 2 times 1, 2. Like normal addition of simple fraction in primary school. Then 4 dividing 4 is 1. 1 times 1 is 1. This will give us 1 over R is equal to, when we add 2 plus 1, we have 3 over 4. Then the next thing is for us to cross multiply. What does cross multiplication mean? Use the value in the numerator to multiply the value in the denominator here and the value here to multiply this. So if we do that, we have 3 times R is 3R. And then it's equal to 4 times 1 is 4. We now make R subject of the formula by dividing both sides with 3. And that will give you 3R over 3 is equal to R 4 over 3. So 3 will cancel out 3. And here you are left with only R. Then 4 divided by 3. 4 dividing 3 will give you 1, 1, remainder 1. You put points and add 1 to the remainder 1 and it becomes 0. 3 dividing 10 will now give you 3. Remainder 1 again. So you will get a recurring decimal 3, 3, 3, 3, 3. And so you approximate to 2 decimal places, which is the ideal. And that will be 1.33 ohms. That's the effective resistance. Then we go to the effective voltage. like we said, V is equal to, what's the value of our V1? 2.66. What's the value of our V2? The same 2.66. And as we said here, that V is equal to V1 and is equal to V2. So, meaning that our V will be equal to 2.66 volts. And then we recall the Ohm's law that we also used in the last class. We said V is equal to IR, where I is the current. And then what's our effective voltage? That's 2.66 is equal to, what's our effective resistance? 1.33. So I, we now make I subject of the formula by letting 1.33 cross over this side, and we now have 2.66 divided by 1.33 is equal to I. And when we divide, how do we divide? Just move. This is 2 decimal places and this is 2 decimal places. Move these 2 decimal places and move these 2 decimal places. You will have, and also this, meaning that you now have 266. See where the point is now. Point what? Nothing else is here, so it means point 0, which is the same thing as 266. The same thing here. This will now be 133 is equal to I. You don't need to use calculator. So you say 133 dividing 266, you get what? 2. So you have 2 amperes as the current. So this is the current. We have obtained the current in the circuit as 2 amperes. Then the last question there is for us to calculate the quantity of charge. And like I told you that quantity of charge Q is equal to IT. But our T is equal to 1.5 minutes. And this 1.5, when converted to improper fraction, we give you 2 times 1, 2, plus 1, 3. That means 3 over 2. Times 60. Why do we multiply with 60? I told you that any time that is not in seconds must be converted to seconds. So we convert it to seconds. So you have 2 here, 1, 2 into 60 is 30. Therefore, we have 3 times 30, which is 90 seconds. Now, the time is 90 seconds. So to find the charge, we say Q is equal to I is what? 2 times our T is what? 90, which will now give us 2 times 90, which is 180 coulombs. So the quantity of charge is 180 coulombs. So I will now give you the one you will solve, and then if you have a question, you drop. I'll give you an assignment, and then you solve and post. Okay, this is the assignment that I have for you. 2 resistors, 2 ohm and 5 ohm are connected in parallel in a circuit in which 2 cells, each of 2.86 volts, are connected in parallel. Draw the circuit diagram, calculate the current flowing in the circuit, and then what quantity of charge flows in the circuit after 1.5 minutes. Now do the assignment, and as usual, submit your assignment and ask questions. Subscribe to my YouTube channel so that you get updates of whenever class has been posted. Thank you.